Hi, Kat here from Lightwave Digital. In this video, we're going to be talking about how to take something from 2015.3, or an earlier version of Lightwave, if you will, to Lightwave 2024. Now, a little bit about this asset that we're looking at right now. This is directly from Iron Sky's production library, which I was the CG supervisor on. Originally built by Thomas Coca-Cola, this asset was at one point in time considered to be the most accurate moon that had been produced in CG, and it was done in Lightwave 3D 11.3, I think. And we had literally rebuilt all of the maps from the lunar orbital program, and it resulted in a moon where we could take the maps and turn them into a displacement map and be able to use subpatch rendering with pixels per polygon in the geometry deformation to create little crevices and actual indentations based off of those maps. So it was extremely accurate. We'd go right into it and it would refine very nicely, and we would get really, really good results with it. And it was used in dozens of shots seen in the film. So a couple of things have changed if you've come from a previous version of Lightwave and you're now just starting out with Lightwave 2024 or above, and that is this geometry tab right here. And there are also a couple of other things to consider working with the surface for something like this. I'm just going to bring the nodal editor over here. In later versions of Lightwave, starting with 2018 and above, because we've moved to a physically based renderer and shader system, we've lost certain plugins or certain node tools, such as Orinar Layer or certain shaders of this nature. And they would normally be plugged into functions like diffuse shading, specular shading, reflection shading, or refraction shading on a regular surface node. As a result, we have to figure out a different way to do this, but there's nothing really much to this map. It's effectively just the color layer, and it was extremely large at 43K in resolution. But there really isn't much to it. Plus, we also have a 46K 8-bit topology map. Take a moment to pull up, because it is 43K. It is a very large map. And see just how big it is. I'm looking at it 10%. It comes nowhere near close to being able to fit on my screen, even at 10%. Well, the point of this is that, yes, we do have this size of image to work with, and that gives us the pixels per polygon displacement. And Lightwave 2015 is actually having some difficulties displaying this, so we not be able to see it until we pull it up into Lightwave 2024. So let's take a look at some of the settings in here. Back in the old days, 13 years ago, when we did this, we need to use a MIP mapping and softness MIP mapping mode. Today, we don't really need to do that because in Lightwave 2018 and above, we've had improvements to the way that Lightwave handles MIP mapping. So this amount of image detail, however, because it was very sharp and a little bit harsh or coarse, we did use a softness mode on this to help reduce any potential for that map when used in displacement or elsewhere from creating points or polygons that would just shoot off into outer space, which was actually a very big problem when we were working with the normal maps. So let's take a look at this now in Lightwave 2024, and we'll see what we get. Now over to Lightwave 2024, we'll load up this scene. This is our Moon Master as I packaged it up from Lightwave 2025, and I know I've got a backup of this, so this warning where it says this is an older version or scene from an older version of Lightwave, loading and converting the scene will probably lose information, and the scene assets not will be compatible with an older version of Lightwave. Do you want to create a safe copy? I'm like, Well, no, because I already did. So I'm going to hit no, but be wise to back up your stuff because sometimes you might want to go back and see how it was for comparison and then transfer settings over. It's especially important if you're coming from Lightwave 2015 or a previous version and you're working in 2024 because not everything translates perfectly across. We'll get an error here. This is totally understandable because the old shading system was in use and we no longer have an Orin Nair node handler that's going to be applicable in this surface. So I'm going to hit no, and it's going to come in, and we're going to get the OpenGL display of this in a moment. Obviously, these images are quite large. I'm not pulling this off of an SSD. I'm actually pulling this off of a spinning metal disk, so it's a little bit slower than I would like, but that's just the way it is. All right, so now we've got this in OpenGL. Pretty much looks identical as to what I loaded initially when I fired it up in 2015. But let's take a look at one thing here. The object properties for this, select the object, hit P, it'll bring up this window. You can see now that we have a displacement stack. These, or the deformation stack, effectively allow us to, say, displace the surface based off of surface displacement. Then we've got a displacement map, which is a texture amplitude boosted 46K 8-bit image, which is the moon topology, or otherwise the craters. We don't need bones, but they're active here, so I can get this out of the way actually, and I can restack it like that. So you can rearrange these at any point in time, and you can add additional modifiers in here. So if you want something like texture displacement, you can add texture displacement, very, very similar to a displacement map. Remove it, move it around any which way you want. Subdivision order can be done before or after. And you'll notice that it did come across with the original pixels per polygon 512 displacement. So this is almost pretty much good to go with one set of exceptions. Because we don't have that ordinary layer plugin in the surface, we've got obviously a specularity map that's in here. That's in the standard surface. We need to consider that. And we need to reproduce what we had before. Now, we can see already that this used to have a node in between it in 2015. That was the Orin Nair node, which gave us a roughness to the surface of the moon. We need to switch this up and go and grab a principled BSDF shader, or material, pardon me, and now we can get access to that roughness value. So first things first, we'll use this color for color. That's a no-brainer. We'll leave the bump the way that it is. It's just going to plug into the material there. Place that material there. We need the specular map, which is at moon color, and we're going to pump it in there at 43%. So let's take a copy of this color, and we'll go 43%. No, 31%, pardon me. 31, 43, 31%. And we'll plug that into specular, and we'll grab an invert node just in case, and we'll take advantage of this in just a second. But now let's take another copy of this color node, and we're going to plug it directly into roughness. And if I recall, that roughness value was around about 31% or 45%. So we're going to turn that down. Now it's time to engage VPR and see what we get for moon. Okay, that's not bad. Got a real nasty hot spot there. So this is where we can take a look at flipping the specular node. So we can either invert it directly, or we can take it and flip it in the node editor with the invert. And if that's not working for us, it might be the roughness needs to be inverted. So those are the two. Yeah, that looks better to me. So then we can just plug in the specular like so. Now when we take our light and rotate it around, let's use light 1, we'll see that we'll get just the hints of the craters. So just taking a little bit of a hint of the light and bouncing it back in a specular manner, which is great. But we need one more function here. Let's take the color layer, copy it again. Let's change this to topology. And let's go 100%. And we'll drive this color output to displacement, because this is now something that we can take a look at. Now, we're not done with this material here for standard. Because it still has all the original OpenGL evaluated textures in here, I can take advantage of this just to make sure that when I'm looking at something in OpenGL, I can just plug it into there and put it off to the side. That way I know at least I've got a map. And everything else in here, specifically the normal map or the bump map, because it remains hooked up as it was when it was imported, will also be reflected in OpenGL preview, the texture shaded solid mode. All right, now we've got the displacement and the surface in there. Let's take a look at the displacement amount. I'm not going to go anything more than 10. But let's take a look at the subdivision amount. We know that it's come in with the pixels per polygon evaluation that match the original. I could probably crank this up a little bit more, but we're looking at this in VPR, and it's not going to give us much of a true evaluation of it because we are looking at this with the display subpatch level of 3. Now I could pump this up to something like 8, and we could start increasing the surface displacement, and you'll start to see that being evaluated a little bit more accurately. But to give us a better idea of what's really going on and how it's going to perform in render, so substitute than actually rendering. Let's make sure our camera is set to something reasonable though, because this has obviously changed. I don't need anywhere near 32 maximum samples. I don't even think I need more than 4 for this to work. But let's hit F9. Keep in mind that these maps still do have errors in them. So if I get a little strangeness in a couple places, it's very much because of the map quality. But it is 32 and or 43 and 46K. So when we had those problems, we would shoot around it or go in and clean it up. I just don't happen to know where those cleaned up images are. This one does do the trick though and serves a purpose. I can get right in on this, even with VPR's display. Now we can hit F9 and we can see that we can start seeing displacement at that level. If we go in even further, we can see that it's starting to break down because this is a little bit closer than the map was ever intended to be used. But if we need to do more displacement or less, we've got the texture amplitude that can be used, or we can use the surface displacement factor. Let's go 150. You can see it's pushing out more in that direction, but maybe that's something we want to do after subdivision. See the change in the stack there? Before, after. Something that was not possible in previous versions. Well, you can see how it's actually improved the look of the moon surface just slightly because it's displacing it afterwards. Let's see what we get when we increase this to say 1024. Okay. More or less the same because there is a certain limit as to where that makes sense. We can see that when we sweep our light across, we actually get full craters, and that crater depth controlled by surface displacement, which is what we've got in the surface editor. Then we've got the actual displacement map. really funky results with this, pushing the map a little bit too much for the amount of geometry that we have in here. So always be wise about that. Well, because we have the ability to now rearrange this, we can add additional displacement types, morph mixer, metamorphic. We can add additional things like texture displacement, Cyflex cloth if you've got Cyflex. Any of the deformers are available and you can restack them based off of the order of operations that you want it to run through to get your final deformed object. So this is something that we had very, very limited control over in previous versions of Lightwave before 2018. And of course, in 2024, its handling is much better. You can also do copy and paste operations for particular types and move them over to different objects. Some fantastic stuff there. Let me just go and dial this back into something more reasonable here. So this was originally at 10. Let's go and add an actual displacement map to this. See what we get here. So we'll go 2D images. We'll load the topo, which is the craters, spherical, Y, automatic sizing. You can see that this is 34 kilometers in size. Still big, but obviously not as big as the moon. And then, of course, just put that input in there. And we're going to displace this in local coordinates. Okay. And then we can enable it. And we can stack it wherever we want and change that around. Keep in mind, some of these things will not display correctly or accurately based off of VPR. You really do need to hit that render, but you can see just how fast this is. Sometimes you'll see people saying that the physically based renderer for Lightwave 2018 and up is slower than what we had in 2015. In some cases, perhaps, but I'm now dealing with something that I can do that much more detailed work to it at the geometry level and really crank things up in ways that weren't even possible in 2015 and would have taken perhaps hours, if not days, of artist time to adapt to that limitation. And now I can just hit F9 or F10 or send it over ScreenRNet and have the problem fixed for me by the software doing what I want. It might be a little bit slower in render, perhaps, and it's not always the case if done properly and set up correctly. But I can let the machines do the work instead of artists sucking up time trying to get that look out of a limited menu system before we had the proper displacement stacking capabilities of Lightwave 2024 or previous versions going back to 2018. All right, thank you for watching.